Do you like trees? I asked ChatGPT this question. I was expecting it to give me something like, oh, I'm a large language model, and I can't have emotions. But instead, it gave me something else. It said, I do, very much. And if I can like something in a human sense, trees will be high on the list because they embody the balance between strength and gentleness. That is a crazy response because it's a language model. It is humanizing itself so that you can talk to it more like a person. But it's just a tool. So what is the difference between the AI and humans? My name is Michael, and I'm not really here to find out the difference between AI and me. I'm a research student doing my master's degree at University of British Columbia. This is a story about how I started doing research, the use of tools, and how all that may relate to the wall of art behind me. Do trees think? Do they have a peace of mind? Well, of course, it doesn't really matter that much to us. Who cares about what the tree thinks, right? We use them for their body materials. But instead, we are also sharing a lot of similarities between trees and us. Our DNA are made of the same bases, the A, C, G, and T. We need to breathe. Trees need to breathe. We need sunlight to make us produce vitamin D or to make us feel a little happier. Trees need them a little bit more than we do. We need to eat. Trees need to eat. We are all living organisms that may or may not have originated from the same ancestor. Of course, trees cannot think like we do. They don't have a central nervous system. They are built very differently, and they have evolved to be very tough in order to protect themselves. But thanks to their toughness, they're also protecting us as well. There's no doubt that wood is an extremely useful and renewable material. Thanks to them, we can live safely and comfortably. Do trees get sick? I mean, they're pretty tough, hard as oak, right? But as the American writer Hosea Ballou once said, disease is the retribution of the outraged nature. Every kind of living organisms get diseases. No one is invincible, and that includes the trees. Do you remember the time when you bought a new plant with excitement and joy, only to find out that it died mysteriously later? That can happen to any of us. And one of the reasons that might happen is probably because we didn't know how to take care of them. But there's also other possibilities. It could have gotten some sort of a plant disease, and we couldn't tell until it was too late. That's essentially similar things that can happen to trees. If we have a plant that died at home, we can just throw it away and get a new one from a shop. But if you're working with a patch of trees and you didn't know why the trees are all suddenly dying around you, that could be a huge problem. That's essentially the same thing that happened to white pine blister rust. White pine blister rust is a fungal pathogen that infects the needles of the pine trees. They're hard to detect at first, but when they reach maturity, they take all the energy from the trees and the trees die. By that time, they release their spores to continue the next generation. White pine blister rust first need to infect another plant called ribes. They develop on ribes first, then release their spores again to infect the pine trees. White pine blister rust is not native. They have been brought here from Europe in the early 1900s, and since then, they have been spreading all the way across North America. Native pine trees have no resistance to them. That means they can die very easily. White pine blister rust is very efficient at killing. The younger trees takes them a short time to kill. Older trees takes them a little longer. One of their targets, white bark pine, is often regarded as a keystone species in the mountains. They're also endangered due to this disease. What exactly is a keystone species? That means if they are taken out by the rust, the organisms around them may also die, causing the whole ecosystem to collapse. Many other mammals and small birds depend on the white bark pine, but the fungi have no mercy. They can't think, after all, but we can. Over the years, people have never stopped finding ways to treat the disease, to stop it from spreading around. But we still lack understanding of the disease. We don't understand how they develop within the needles. We don't have an efficient way of detecting them when they first infect a needle. They're hard to detect when they are not producing spores. That's what I'm here to find out with spectroscopy that can potentially solve this problem. Spectroscopy is also widely used in agriculture, but it's not yet used in forestry that much. Well, what is spectroscopy and how do we use it? In simple terms, spectroscopy is shining different colored light on a subject to see how it transmits or reflects. Now, some people may ask, what is light and what is color? Those are simple words, but they may be hard to define. Let's imagine this. Light is a form of energy that travels in waves. The distance between each wave determines the color of the light. A spectrometer is the machine that lets us see how a test subject reacts to light of different colors. You can even make one for yourself for a few dollars. Here's a video to show you how to make one at home. Now, the one that we are going to use in the laboratory is going to be much, much more expensive and specialized. Introducing the SVC 1024i spectral radiometer. This right here is the HR 1024i spectral radiometer made by a company called SVC. It is a very specialized piece of equipment. It's also very nicely crafted, but also it's very, very expensive. That costs around $130,000. And the fun thing about this equipment is that it comes with an Android phone, or specifically a Samsung phone, to help you visualize and use their specialized software to control this equipment. Now you might wonder, why is this spectral radiometer, or whatever it is called, so expensive? That kind of applies to all sorts of laboratory equipment. They are very expensive. But why? Let's break it down a little bit. But let's not break it. First, they're very specialized machines. That means they're created for very specific purposes that the general public may not use them for. Secondly, they have to be made very, very precisely in order to give us the best accuracy. In a research setting, we definitely need the best accuracy possible in order for our results to not have any bias. Spectroscopy is a very powerful tool in detecting diseases. It has been proven in many other papers in agriculture to show you how useful and efficient it may be. If those claims are true, then that may significantly shorten the time that we detect the white pine blister rust hiding within those needles, which will make the tree breeding process much faster. Time is precious in fighting the invasive disease. If spectroscopy is as good as the other people say, then that's what I'm here to find out in the forestry setting. Now, the spectral radiometer is here in our lab. I am ready to do my research with spectroscopy techniques in the detection of white pine blister rust. Or am I? Have you ever feel like you're spending way too much money? That often happens when you're investing in a new equipment that is expensive, like a new camera set, or a new instrument, or maybe a new laptop. Certainly, coming from a middle-class family in China, I often feel guilty when making a big purchase. My dad often thinks that I'm spending way too much money on expensive gear that I really don't need. Well, that's okay, because sometimes he might be right. I probably don't need this expensive set of cameras to film this video. But that's not how we should think about this. Do you sometimes feel that you don't deserve the equipment that you're using? Well, you may have the imposter syndrome. Yes, you heard it. The imposter syndrome is someone who often doubts their skills or accomplishments. This is a term first proposed by Pauline Rosanne Clance and Suzanne Ament in 1978. Someone with the imposter syndrome often thinks that, oh, I don't deserve to use the equipment that I'm using. I'm not skilled enough to do something, I'm not smart enough to do research, or I'm not good enough to use this specialized spectral radiometer. Those are all examples of this imposter syndrome. But we shouldn't feel this way. You probably don't need it, but you really want it. It gives you joy, it gives you meaning, and it makes you happy, and it makes you creative. I think that's enough reasons to justify anything. Research may also be like this. We probably didn't need to spend this amount of money or other resources or time into this project, but we did. I probably could have gone away with doing any other career, not doing any research, or go straight to work to do something else. But I choose to do research because it gives me joy. It makes me feel proud of myself for trying to help with one of the world's problems. Just like how this wall of art behind me is created. The symbols for education. First built by Leonel Thomas and Patricia Thomas in 1958, restored last year. It probably didn't need to be here. It was probably costly to renew, but it was built with goodwill to serve people, to give people a place to think, to inspire, or a room for the artist to be creative. And it has certainly made my life on campus a little bit better. So turn your passion and interest into action. Use whatever tool you need to complete that goal, and don't ever feel guilty about using them. I asked ChatGPT again about what it can do about liking trees. It gave me a great response. I can't physically plant a tree, but I can help people to plant the idea of caring about them. I think that's a great use for the tool. And it was never about them in the first place.
어디 찾고 있을까요?